There's a single unsolved math problem that, if answered the wrong way, could shatter every password on Earth. Not with a virus. Not with a hack. With a proof. Every bank, every crypto wallet, every login screen you've ever used is quietly betting on this problem staying unsolved. And here's the terrifying part, nobody has ever proven the bet is safe. It's called P versus NP. It sounds like abstract math trivia. It's actually the invisible foundation the entire digital economy is standing on. Let me show you what it really means, and why the smartest computer scientists alive are genuinely afraid of the answer. Start with a simple idea. Some problems are hard to solve, but easy to check. Think of a jigsaw puzzle. Assembling it takes forever. But if I hand you a finished puzzle, you can verify it's correct in a glance. That gap, hard to solve, easy to check, is the heart of everything. Computer scientists gave those two categories names. P is the set of problems a computer can solve quickly. NP is the set of problems whose answers can be checked quickly, even if finding them takes eons. Every problem in P is obviously in NP. If you can solve it fast, you can check it fast. The billion-dollar question is the reverse. Is every problem that's easy to check also secretly easy to solve? In other words, does P equal NP? If yes, then every problem we think is hard actually has a fast shortcut we just haven't found yet. That might sound like good news. It's not. Because the hardness of these problems is exactly what keeps your secret secret. Here's how your online security actually works. When you log in, your password isn't stored as text. It's run through a one-way function that's easy to compute forward and nearly impossible to reverse. Encryption uses the same trick. Multiply two enormous prime numbers together, and you get a gigantic number. Easy. But take that gigantic number and try to figure out which two primes made it. That's brutally hard. So hard that the fastest supercomputers on Earth would take longer than the age of the universe to crack a single strong key. That difficulty is the lock on every door in the digital world. But notice something. Checking whether a set of primes is correct? Instant. Finding them? Practically impossible. That's an NP problem, sitting right at the center of your bank account. Now imagine someone proves P equals NP, and worse, hands us the actual fast algorithm. Suddenly, that impossible reversal becomes easy. Factoring huge numbers? Fast. Reversing password hashes? Fast. Every encryption scheme built on that difficulty collapses at once. Not one bank. Every bank. Not one wallet. Every wallet. Secure messages, military communications, digital signatures, the little padlock in your browser, all of it assumes these problems stay hard forever. That assumption has never been proven true. Let that sink in. The entire security of modern civilization rests on a mathematical guess. We assume P is not equal to NP. We build trillion-dollar systems on it. And we have no proof. So why do experts still sleep at night? Because the evidence leans hard one way. For over 50 years, thousands of brilliant people have attacked thousands of NP problems, hunting for shortcuts. They've almost always failed. And there's a beautiful twist that makes the stakes even higher. Many of these hard problems are secretly the same problem in disguise. They're called NP-complete problems. Crack a fast solution to just one of them, and by mathematical necessity, you've cracked all of them. The whole category falls like dominoes. Scheduling flights, routing delivery trucks, folding proteins, designing microchips, all of these hide the same core difficulty. One shortcut would rewrite science, medicine, and logistics overnight. Which is why P versus NP is one of the 7 Millennium Prize problems. Solve it, prove it either way, and the Clay Mathematics Institute hands you $1 million. But honestly, $1 million undersells it. If you proved P equals NP with a practical algorithm, you could arguably drain every cryptocurrency wallet on the planet before lunch. The prize is a rounding error. Here's the part almost nobody appreciates. Even a proof that P is not equal to NP wouldn't just make us feel safe. It would finally explain, mathematically, why some problems are genuinely, permanently hard. It would draw a hard line between what computers can do and what they never can, no matter how fast they get. That line is one of the deepest mysteries in all of science. And there's a philosophical gut punch hiding inside. If P equaled NP, creativity itself might be automatable. Finding a brilliant proof would be as easy as checking one. The very idea of a hard problem would dissolve. Most researchers bet that will never happen. But bet is the key word. Your passwords, your money, your private life, all of it hangs on a coin that's still spinning in the air. So the next time you type a password and see that little lock click shut, remember what's really holding the door. Not steel. Not code. A single and proven assumption in mathematics that, so far, has always held, but nobody can promise ever will.